All right, hello class, welcome to Friday's lesson. Today we're picking up where we left off yesterday. We talked about sequences, okay? Today we're going to go in a little more specific. We're going to talk about the recursive arithmetic sequences, okay? It's really just piggybacking off of last class, okay? So it's not going to be too difficult. If you thought last class went pretty smoothly, then today should go more or less the same, okay? But we're going to look at patterns just like we did last time. So looking at this first example, okay, I've got a bunch of blocks and it's increasing each time. So let's find out how much it's increasing by each time. On this first set of blocks, I've got 3 blocks. Then down here, let me rewrite that 3. Then on the next one, I have 1, 2, 3, 4, 5, 6 blocks. Then on the third one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 blocks. Okay, so I'm starting to see a pattern here, right? I'm going from 3 to 6 to 9. Looks like I'm just adding 3 each time. So up here, when it says how many blocks would be in size 4, well, that's pretty easy. You just add 3 to 9, right? And you get 12 blocks. Then how many would be in size 5? Well, you just add another 3, you'd get 15. Okay, then it asks how many blocks would be in size 10. Okay, well, if I'm starting at size 5, I know I already have 15 blocks. Then, from 5 to 10 is 5 different jumps. So I'm going to have 5 different jumps of 3. So there's 1, 2, 3, 4, and 5. So 15 plus 3 plus 3 plus 3 plus 3 plus 3 is 30. Okay? So because I know that I'm increasing by 3 every time, I can just say, okay, well, I have 5 3s. So 5 times 3 is 15 plus 15, 30. There you go. Okay, now describe the pattern in words. Well, I start with 3 blocks, okay, and I add 3 each time. There we go. Now we need to draw the shape that would come next. So the shape that would come next is size 4, which we said there was 12 blocks. So let's draw this shape. Already messed up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I drew that one off, but that's okay. You get the gist. It should look something like this. There's 12 blocks. That's fine. Okay, moving on. Pattern number 2. Let's see if we can find this pattern. How many do I have in this first one? Well, I have 5 little cubes. Then on the next one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then on this last one, 3, 6, 9, 12, 15, 16, 17. Okay, so from 5 to 11, I added 6. And from 11 to 17, I added another 6. So it looks like my pattern is at 6. So what would the next number be, or size 4? Well, 17 plus 6 is 23. And then, what would the next one be? Well, 23 plus 6 is 29. And then what would size 10 be? Well, if we start at 5, we have 29. And then we add 6. We add another 6. Add another 6. Add another 6. Add another 6. Then we're at 10. So 29 plus 6 plus 6 plus 6 plus 6 plus 6 is 59. Okay? Now we need to describe this in words. Well, you start with 5 and add 6 each time. Okay? And then draw the shape that would come next. I'm going to leave that up to you guys. Just draw the next shape right over here. So you can pause the video and come back or draw it later. Up to you. Okay. Pattern 3. Now, in this pattern, we are only looking at the white squares. On your screen or on your papers, the blue ones are probably black. But we only count the white ones, okay? So on this first box, I have 4. Then on this second one, I have 1, 2, 3, 4, 5, 6, 7, 8. Then on this third one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the pattern looks like it's going up by 4 each time. So what would the next box be? It would be 12 plus 4, which is 16. Then the one after that, 16 plus 4, which is 20. And then, how many squares in size 10? Well, we're starting at 5 with 20. We need 5 more. So 20 plus 4 plus 4 plus 4 plus 4 plus 4, which is 40. Okay? Now describe this in words. You start with 4 and add 4 each time. Okay. And then I'll leave you to draw the next box. So far, we haven't really done anything really new. So far, we're just like looking at patterns, which is what we did last time, right? So this is where the new stuff is going to come in, right after this, okay? So we need to go over a couple vocabulary words, all right? So an arithmetic sequence is a list of numbers, okay? Well, I'll say adding or subtracting number patterns. So an arithmetic sequence is an adding or subtracting number pattern, okay? So like I said, I think at the beginning of the last lesson, a sequence is just a list of numbers, okay? And it could be random numbers that have no sense why they're connected. But specifically an arithmetic sequence is when you're either adding or subtracting to get to the next number, okay? Now, there's something called the common difference, which we denote with a D, okay? The common difference, okay? That is the number being added or subtracted, okay? All right, so the difference, the common difference, is the number that is either being added or subtracting. That's how you get from one number to the next number in an arithmetic sequence, okay? Now, the recursive part of these sequences is because we reuse the old term. So like how last class we were saying a sub n minus 1, we're reusing previous terms, okay? So for the recursive part, that's because we reuse old terms. And then a recursive formula So the formula that we're going to need today looks like this. It's a sub n is equal to a sub n minus 1 plus or minus d. Okay? Because d can either be added or subtracted, so we shorten it down by saying plus or minus. Okay? So that's the formula you're going to need today, because we're going to be making these formulas today. Okay? And then just a reminder, a sub 1 is the first term. Okay. So we need to make a recursive formula for this sequence. Okay? So we need to say what our first term is. Okay, so we need to say a sub 1 is, and what is our first term? Well, our first term is 2, right? So a sub 1 is 2. Okay, perfect. That's the first part done. Then we need to use this formula to make this into an equation. Okay? So we're going to say that our formula is going to have an a sub n. That's the new term. It's going to be equal to the previous term, a sub n minus 1. And now we need to figure out what is our difference. Okay? So how did I go from 2 to 6? Or, excuse me, from 2 to negative 6. I subtracted 8. Okay? Let's make sure that that is the difference. Okay? From negative 6 to negative 14 is also subtract 8. So it looks like we're in the clear here. Okay? So our difference is negative 8. So I'm going to plug our difference into the equation. I have a subtract 8. So I'll subtract 8 here. All right? That is my equation. There's nothing else I have to do. Okay, so if I were to find, like last class we said, find the 6th or the 5th term, right? Then I would just use this formula to find the 6th term. Okay? So we're basically doing the opposite of what we did last time. Okay? So down here at the check your understanding, okay, wants us to give the first 5 terms in this pattern. Okay, well, we have a picture over here. We can easily find the first 3. Okay, well, there's one block here. Then there's 1, 2, 3, 4, 5, and there's one underneath this. So there's 6 blocks here. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus that block that's hiding. So there's 11 blocks there. So 1, 6, 11, those are our first 3 terms. We just need the next 2. So how did I go from 1 to 6? I added 5. And how did it go from 6 to 11? I also added 5. So to find my next term, I'll go 11 plus 5, which is going to give me 16. And then to find my last term, 16 plus 5, which is 21. Okay? So why is this sequence arithmetic? It's because we're adding 5 every time. If there was no pattern, like if there was no way to connect these numbers, then it would not be arithmetic. It would just be a sequence. It would just be a list of random numbers. Okay, now C, identify the common difference. We kind of already did this. We just didn't put it down. But the difference here is 5, right? I'm going up by 5. So you can either say plus 5 or just 5, whatever. But the difference is 5. You're moving up 5 every time. Okay, and now we we need to make a formula for this. So just like the last one, we need our A1. What are we starting with? A1 is just 1, right? So A1 equals 1. And then I use that formula from up above. So remember, it looks like A sub n is equal to A sub n minus 1, and then plus or minus our difference. So our difference is plus 5, so it's A sub n minus 1 plus 5. And that would be the formula for this sequence. Okay? Okay, number 2, we need to find the first 5 terms. That should be pretty easy. This is just like a review from last time. So starting with A sub 1, it is 4. Whoops. So 4 is my first term. Okay, now the formula says you're just adding 1 each time to the previous. So 4 plus 1 is 5. Then 5 plus 1 is 6. Then 6 plus 1 is 7. Then 7 plus 1 is 8. And that is the first 5 terms. Okay, so not too bad. And the last one, I need to write a formula to find the nth term in the sequence. So I'm just writing a formula. I need to find what my difference is here. Okay, so how did it go from 18 to 12? I subtracted 6. And how did it go from 12 to 6? I also subtracted 6. So it looks like my difference is negative 6. So let's make a formula. I need my A sub 1. A sub 1 is 18. And now I need to write my formula. If you don't like this weird looking A, I know I'm not very good at writing it. You can just use regular A's, by the way. So A sub n equals A sub n minus 1. And then my difference minus 6. So that is the formula for that sequence. Okay, so delta math, you're going to go on. There's one that's just finding the difference. So all you need to say is the difference is 5 or negative 3 or whatever it is. There's one where you're going to, it's a multiple choice. You're going to choose which one's the correct equation. And then the last set of problems is it's going to give you a list of numbers, or a sequence, I should say, and you have to make the formula from that list of, or from that sequence. Okay? If you have any questions, email me or hold off and I can answer them next week.